Hello, this lecture is about electric charges. Let's go through some definitions and applications. Let's start talking about the types of electric charges we have. We have particles with positive charges, the protons. We have particles with negative charges, the electrons. And we also have some particles that have no charges. These are the neutrons. We also know that particles with opposite signs, they attract each other. On the other hand, particles with the same charges, they tend to repel each other. A good example on how these electric charges act is when you rub a balloon all over your hair and now your hair is all messy and the balloon starts to attract your hair. So what's happening here? This is called the Triboelectric effect. What you're actually doing, you're stealing some electrons from your hair by friction. That's the friction electrification. So when you steal the electrons from your hair, now the balloon has more electrons, it's with a negative charge, and your hair has less electrons, and now it's with a positive charge. And as you remember, opposite signs here in charges attract each other. That's why your hair starts to be attracted by the balloons. So how do we quantify the charges? Well, that's why we have an elemental electric charge that we represent with a small letter E here. We usually use Coulomb as a unit of measure. A Coulomb is approximately 6.24 times 10 to the 18th the charge of one electron. So, one electron has a charge of the inverse of this number here, which is 1.6 times 10 to the negative 19th Coulomb. This unit here, Coulomb, is named after Charles Augustin de Coulomb. He was a French scientist and he was the first guy to start measuring the electric charges. One thing that you have to keep in mind is that charges can only exist in integer multiples of E of an electron. Another important concept we have to know when talking about charges is the law of conservation of charges. It's pretty simple. It just says that if you add all the charges inside a system, of all the particles inside the system, it has to be constant. So, well, how does we make sense out of it? Let's take, for example, this small box here as our system. It's electric isolated, so we have no charges going out or in the system, and it has 3 particles. If we add the charges of these particles here, we have a resultant charge of negative 2 coulombs. Let's imagine now that for some reason these particles changed into 5 other particles. It can happen because of collisions or decays of some elements, and we have now 5 particles with different charges from the initial ones. Well, by the conservation of charge, we know that the resultant charge here has to be equal to the resultant charge here. So how do we find the charge of this particle X that is missing? Well, we can just add all the charges of the particles here and say that's equals negative 2 Coulomb. And if you do the calculations, we find that the charge of this particle here is in fact negative 2 Coulomb. So it doesn't matter how many particles, if it changes inside the system, the result has to be the same. Another good example of the conservation of charges is when we have decays in elements. Imagine we have this element here, K, just as an example, okay? And it has a charge of -7 Coulomb. And after decaying, it decays to 3 other particles, Z, X, and Y. We know that the charge of Z is -4, charge of X is -1. So what is the charge of the missing particle here? So if we add -4 plus -1, we have a -5. So we're missing something. By the conservation of charge, it needs to be -7. So by the same reason, if you have -5, we're still missing -2 coulombs here. Okay, now it's your turn to test your knowledge. So imagine we have a nuclear scientist and he's doing his experiment and he found a charge of 15.1 times 10 to the -19 Coulomb. Is it possible? Remember that we only have charges, existing charges, that are integer multiples of E. Also, another problem, in a particle decay experiment, a particle X with charge positive E is seen to decay to form 3 new particles. One of the new particles has a charge of -E, and another particle is neutral with 0 charge. So can you tell what is the charge of the third particle? Your turn, think about it, and write in the comment section. Thank you.
If you're looking for similar topics, check out our other videos and don't forget to subscribe.